Chapter 12, Climate Change. What you will about to discover in this chapter is the things or topics that causes climate change. First stop, Earth's movement around the sun.
The Earth, like all other planets in the solar system, revolves around the Sun in an elliptical orbit, and it also rotation on its axis. These are two important motions of the Earth, that is rotation and revolution of the Earth, are responsible for many phenomena on the Earth, like day and night, four seasons. All these phenomena depends on rotation and revolution motion of the Earth. So, what is the rotation? Rotation is the spinning of the Earth on its axis. The axis is the imaginary line, which passes through the center of the Earth, connecting to the North Pole and the South Pole. Earth axis is tilted at angle of 23.5 degrees from the vertical and different line were drawn, parallel to plane of Earth's orbit. The axis will make 66.5 to this line. Now, let's understand the characteristic of rotation. The Earth completes one rotation from west to east on its axis within 23 hours 56 minutes 4.09 seconds, which roughly comes to 24 hours. The Earth is always tilted in the same direction, that is pointing toward pole star. That is North Pole pointing toward pole star as moving around the Sun. And the speed of movement at the equator is 1,660 km per hour. The Earth revolves the Sun in elliptical orbit, that is orbit appeals ellipse. Ellipse means a longitude circle. When the Earth revolving the Sun in elliptical orbit, we call that revolution of the Earth, and this lends to areas phenomena. If you see the revolution of the Sun is not the center of ellipse, the Earth revolving around the Sun, direct times when it closer to the Sun, that is called perihelion, and direct times farthest to the Sun, that is called aphelion. The Earth come closer to the Sun, that time speed of the revolution around the Sun increases, and when they are far away from the Sun, the speed of the revolution of the Sun reduces. This namely because of the gravitational force of the Sun. Earth complete one revolution around the Sun in 365 days, 5 hours, 48 minutes, and 45.51 seconds, but we roughly take it these 365 days and 6 hours. Just these 6 hours, we have a concept of a leap year. A leap year comes once a fourth year. So on the 4th February, instead of 28 days, we have 29 days. And in this way, we adjust these 6 hours. Let us learn the effect of revolution of the Earth. The first effect is the seasonal changes. Because of the revolution of the Earth, we have the phase of spring, second phase summer, third phase autumn, and third phase is winter. Now, how does this happen? Suppose we take this fourth position of the Earth. In this first position, the date is 21st of March. In the second position, it is the 21st of June. In the third position, it is the 23rd of September. And the fourth position, it is the 22nd of December. The Earth is in second position. If you look carefully, the northern hemisphere is facing the Sun. And then the Earth is in the fourth position. This southern hemisphere is facing the Sun. But when the Earth is in the first position or in the third position, none of the poles are facing the Sun. So the inclination of the Earth axis that have not any impact of the sun rays, that is it received. So on the 21st of March, vertical rays of the Sun fall on the equator, and the entire Earth has equal day and night. But it is moving from the first position to the second position slowly. The northern hemisphere tilts toward to the Sun. So on the northern hemisphere, the days become longer and the night becomes shorter. And this gives rise to summer condition. This is referred to as spring equinox. On the 21st of June, the vertical rays of the Sun falls on the tropic Cancer. This is the maximum inclination of Earth axis of the northern hemisphere towards the Sun, and this is referred to as summer solstice. When the Earth comes to the third position, entire has equal day and night. This is referred to as autumn equinox. As we come to the fourth position, the date of 22nd of December, southern hemisphere is facing the Sun, and the vertical rays of the Sun falls on the Tropic of Capricorn, and this is the time the northern hemisphere experiences the winter solstice. So on the first and second position are referred as equinox because it is equal day and night. Equinox refers to the time. The sun at noon is directly over the equator. It happens twice a year and causes an almost equal length of day and night. The second and the fourth position referred as solstice because when the sun at noon sits above the tropic Cancer or the Capricorn. The summer solstice has the longest period of daylight in the year, and the winter solstice has the shortest period.
Now, for the second stop of this journey, the Milankovitch Parameter. Hundreds of different types of cycles in our world and in the universe. Some are natural, such as the change of the seasons, annual animal migrations, or the circadian rhythms that govern our sleep patterns. Others are produced by a human, like growing and harvesting crops, musical rhythms, or economic cycles. Cycles also play key roles in Earth's short-term weather and long-term climate. Milankovitch parameter consists of 3 cycles, but before that, let's know first who's behind on this. Martin Milankovitch, Serbian astrophysicist who began investigating the cause of the Earth's ancient ice ages in the early 1900s. According to American Museum of Natural History, Milankovitch cycles are 3 types of Earth orbital movements affect how much solar radiation, or known as insolation, reaches the top of Earth's atmosphere as well as where the insolation reaches. Milankovitch cycles describes how relatively slight changes in Earth's movement affect the planet's climate. Earth experienced its most recent ice ages during the Pleistocene epoch, which lasted from 2.6 million years ago to 11,700 years ago, or thousands of years at a time. Even the more temperate regions of the globe were covered with glaciers and ice sheets, according to the University of California Museum of Paleontology. To determine how Earth could experience such vast changes in climate over time, Milankovitch incorporated data about the variations of Earth's position with a timeline of ice ages during the Pleistocene. He studied Earth's variation for the last 600 years and calculate the varying amounts of social radiation due to Earth's changing orbital parameter. Milankovitch calculations and charts, which were published in the 1920s and are still used today to understand past and future climate, lead him to conclude that there are 3 different positional cycles, each with its own cycle length, that influence the climate on Earth. Eccentricity. Earth's orbit isn't perfectly circular, but it's pretty close. Currently, Earth's eccentricity is near at its least elliptic, or most circular, and is very slowly decreasing in a cycle that spans about 100 years. Jupiter and Saturn causes Earth's orbit to nearly circular to slightly elliptical. Total change in global annual insolation due to the eccentricity cycle is very small. They are relatively minor factor in annual seasonal climate variation. Obliquity. Earth's axis is tilted as it travels around the sun. This is why Earth has seasons. More solar radiation during summer when hemisphere is tilted towards the sun. Less solar radiation during winter when it is tilted away. As obliquity decreases, it gradually helps make our seasons milder. Over time, allows snow and ice at high latitudes to build up into large ice sheets. Axis is at minimal tilt. The amount of solar radiation doesn't change much of Earth's surface, therefore seasons are less severe. Precession. As Earth rotates, it wobbles slightly upon its axis, like a slightly off-centered spinning top. Axial precession makes seasonal contrast more extreme in one hemisphere and less extreme in the other. Direction of this wobble relative to fixed positions of stars is known as axial precession. Apsidal precession. Not only does Earth's axis wobble, but Earth's entire orbital ellipse also wobbles irregularly. Milankovitch combined the cycles to create a comprehensive mathematical model for calculating differences in solar radiation with corresponding surface temperature. Calculated ice ages occur approximately every 41,000 years.
Global warming. Global warming is the long term of Earth's climate system discovered since the pre-arrival period. Between 1850 and 1900s, due to the human activities, fossil fuel burning, which increases the heat trap of greenhouse gas levels in the earth. This kind of topic shows that the earth is getting hotter and hotter because of what's the human activities like burning plastics and factories and um, vehicles, uh, and this kind of smoky parts will destroy the ozone layer, and um, nothing will cover in the earth, and that's why um, the heat of the sun is getting hotter and hotter.
Greenhouse gases.
This Earth atmosphere consists of gases, such as oxygen and nitrogen. Other gases known as greenhouse gases, like carbon dioxide, methane, and chlorofluorocarbons. Incoming light from the sun hit Earth's surface. The Earth absorbs some of that energy, heating the surface planet. The rest of that energy reflected, and the sum of that energy back to the space. This is known greenhouse effect, the exchange of incoming and outgoing radiation that warms the Earth. The greenhouse effect is essential in order to keep our planet warm, but too much is something bad, right?
Greenhouse is full of windows that let in sunlight. That sunlight creates warmth. The big trick of a greenhouse is that it doesn't let that warmth escape. Overall, greenhouse gases are a good thing. Without them, our planet would be too cold and life as we know it would not exist. But there can be too much of a good thing. Scientists are worried that human activities are adding too much of these gases to the atmosphere. According to British engineer John Tyndall, however, was concerned as to what would become of the Earth's atmosphere if industrialization become widespread. Since machines are primarily used in an industry, the production of electricity by means of burning fossil fuel, usually coal, increases. In a century's time, the situation changed. This led Charles David Keeling, an American scientist in the mid-20th century, to find out if the increased burning of fossil fuel and the consequent release of carbon dioxide in the atmosphere were changing the global temperature of the atmosphere. Keeling curve data that shows carbon dioxide emissions over time. This issue concerns many nations since not burning fossil fuels may mean not industrializing or modernizing. Future actions. If we want to industrialize but at the same time protect the environment, then a balanced plan must be created. Science has given humanity a tool for modernization. It allows for the emergence of technology that spreads and applies knowledge for the attainment of the good life. It must be realized that science is more like a cookbook than a blueprint. It is open for experimentation, innovation, and refinement. So, like any good chef, reading it requires a fine sense of taste.